Let's take a look at these and see how it's going so far. The first few are pretty straightforward here. Number one, blank is 40% of 70. Well, the 40% is 40 over 100. Of 70, remember that implies out of 70, so the 70 goes on bottom. We cross multiply and divide. So 40 and 70 are diagonal. We multiply those to get 2,800, and we divide by the 100 to get 28. So 28 is 40% of 70. Number two, blank percent is blank over 100. So we still start with the percent even though we don't have it. 27 is blank percent, implies the 27 goes on top. Out of 30 puts the 30 on bottom. And again, we cross multiply and divide. 100 times 27 is 2,700. Dividing by the 30 gives us 90. 27 is 90% of 30. And the third one, blank is 140%, or 42 is 140% of blank. Well, 140% is 140 over 100, as always. We see that that percent is bigger than 100, so it tells us the portion here is going to be bigger than the whole thing. 42 is 140, implies the 42 goes on top, and our missing numbers on bottom. 100 times 42 is 4,200. Divided by the 140 is 30. 42 is 140% of 30. Number 4 here is one that I gave you information that makes it very, very difficult to figure out what's going on here. And I put it up there because we're so stuck on the out of 100 thing when it comes to percents that we don't realize that in a proportion, all we have to do is match up things that represent the same thing. So in a problem like this, we have 3 numbers we're looking at. We're looking at the list price or the full price. From that, we are subtracting a discount to get an amount paid. And as we mentioned yesterday, in a percent problem, every number is described by two, or every item is described by 2 numbers. One is a percent, and the other is a count or a dollar amount. In this case, it is a dollar amount. So we have a $217 discount. So that goes on the dollar amount side of the discount. Kelly pays $2,883. That goes on the dollar side for the amount paid.
Didn't you say it was 217?
Did I say 217? Nope. Yeah, it should be 217. Oh, sorry, 217, not 219. You're correct. Thank you. Now looking at this, for the percents, it doesn't look like we're given anything. But remember, there's always 1% that we know. And that is 100% is that base amount or the starting amount. In this case, that would be the list price. We're not given any other information here, but we can find it rather quickly because we know that this list price here can be found by taking the amount paid and adding the discount back to it, which would be $3,100. We're asked to find what percent is the discount. That's this amount right here that we're asked to find. We're not used to variable notation. I'm going to put a empty box here. So now what this is telling us is we have 217 out of 3,100. So our percent discount is blank out of 100. 217 represents the discount, and that's what we're looking for. And that's out of 3,100. Notice, by the way, this table helps us line things up. it tells us that the 100% and the 3100 line up, and that our missing number and the 217 line up. Now it's just a matter of cross multiplying and dividing. 100 times 217 divided by 3100 is 7. So 7 out of 100, or 7% discount. So this is one of the things we touched on a little yesterday at the end, of making sure you know what the numbers represent. You can't match up a percent with a number that represents something else. Here, if you want the 100%, you have to find the dollar amount that represents that base amount that the 100% goes with. How many of you put 217 over 2883 here? And that's what most people jump in and try to do. Okay, so our next step. Let's look at some applications of these percents. We had mentioned yesterday that there's a rate method of percent, and that it is most useful when we know the base amount and we're looking for the portion. And one of the applications that we gave where that is very common is in interest. So I'm going to talk a little bit about interest today. I'm going to start out talking about simple interest. Simple interest is called that because that is the simplest way really to calculate interest. In simple interest, interest is only calculated if one of two things happen. One, the end of the term. You might put money in a 3-month CD that's simple interest. That you put the money in there for 3 months, and then on the last day of the term, they calculate the interest and add it in right before the CD expires. Or two, if there's an action on that account. By an action, I mean you either draw money out or pay money into that account. So the formula for interest, the amount of simple interest, is I equals P times R times T. Where I is the dollar amount of interest. P is the principal. Principal is your base amount. That's the money you start with. That would be your 100%. R stands for rate. Remember, rate is a decimal form of a percent. And T is time, always given in years. So this is our rate method. You have 100% of the base amount, which is the principal, times the rate, and then it is modified for the period of time. If it's a 1-year term, then this is exactly our rate method of percents. So let's say you invest $2,000 at 2.8%. for 1 year. The interest, I, equals your principal, $2,000, times your rate, 2.8% as a decimal is 0.028, times your time of 1 year. That multiplies out to give you $56 in interest for that year. There's something else called maturity value. Maturity value is the balance at the end, or the balance after interest. And this formula is pretty simple. The maturity value is just equal to the principal that you started with plus whatever interest you earn. So for this example up here, the maturity value would be that principal of $2,000 plus the interest of $56 would be $2,056. So I might ask you to find the maturity value of $4,000 invested at 8% for 3 years. Well, let's work through this one together here. First thing we do is find our interest. That's our principal of $4,000 times our rate, 8% becomes 0.08, times our time of 3 years. 4,000 times 0.08 times 3, I believe that's $960. So then our maturity value is found by taking our principal of $4,000 plus our interest earned of $960 to give us $4,960 maturity value. That's our balance at the end of that term. So in your notes, I want you to find the maturity value of $7,000 invested at 4%, 10 years. I'll give you a minute to find that, and then we'll go over it. The first step is to find the interest. Interest equals the principal, $7,000, times the rate, 4% becomes 0.04, times our time of 10 years. Well, 7,000 times 0.04 times 10, 2,800. Our maturity value is the original 7,000 plus the interest earned of $2,800. Give us a maturity value, $9,800. Now, some of you might have realized the last couple of examples are not very practical. Banks and other investment institutions do not like doing simple interest for 10 years or even 3 years. Pretty much anything over 6 months, they would never do simple interest. And in many institutions, anything over 3 months, they won't do simple interest on. So it makes more sense, it's more practical to do our simple interest with a shorter period of time. So let's look at finding the maturity value of $5,000 invested at, let's go 4%. Three months. How is that going to work? Well, let's find our simple interest first. Our principal is $5,000. Our rate, 4%, becomes 0.04. Our time, 3 months. Now remember we said the time is always in years. So to express 3 months is years, there's 12 months in a year, so we express that as 3/12. Which I believe that comes out to be $50. Now, when you punch this in your calculator, you don't have to do a fraction for the 3/12. You can just do times 3 divided by 12. And yes, it is $50 is our simple interest. So the maturity value, the $5,000 plus the $50. $5,050. So these simple interest is typically used on these shorter term loans. Although you might be surprised on loans that you might have that actually are simple interest. Some of them are modified simple interest, but if you have a car loan, most auto loans are actually simple interest. Now you might say, well, but they charge me interest every month. Yes, but remember we said there was 2 times where they calculate the interest. One is at the end of the term, but the other is if there's an action on that account. And when you have a car loan, they expect you to make a payment every month. So the interest gets calculated and added in when you make that payment. Actually, it's added in an instant before you make the payment, is the way they calculate it out. So you can actually control how much interest you get charged for a particular payment by how you make it. If you ever notice, if you make a payment really early one month, then the next month you make your payment, right on time, there's more interest on that second month's payment because there was a longer period of time. Well, I want to take a look at those longer terms now. Anything over 3 or 6 months, banks will use, or any investment institution will use something called compound interest. And what compound interest is interest is calculated every set period. And it's added in. It's added to the balance. And then after that, you get interest on the interest. That's why it's called compound interest. Is you get interest on the interest compounded upon the interest. So let's go back to one of our previous examples here. I'm going to abbreviate it here. $4,000 at 8% for 3 years. But we're going to change this just slightly. It's going to be 8% compounded quarterly. So that compounded quarterly means that every quarter of a year or every 3 months, the interest is calculated and added to that balance. So we're going to have our quarter. We're going to have the interest. Actually, let's do this. Let's do a beginning balance first. Then let's do the interest. Then do the ending balance. So in our first quarter, the beginning balance, of course, is the principal of $4,000. Our interest is the principal of $4,000 times that 8%, 0.08, times 1/4. It's only a quarter of a year. That gives us interest of, was that $80, I believe? And it is $80. So our ending balance is the 4,000 plus the 80, or $4,080. Well, we start quarter 2, that $4,080 that we ended quarter 1 with becomes our starting balance, our beginning balance. So our interest is $4,080 times 0.08 times 1/4, giving us $81.60 as our interest. Notice the amount of interest for that quarter has gone up already because we had the interest from the previous quarter added to the balance. So this gives us an ending balance of $4,161.60. And as we continue, that $4,161.60 would be our beginning balance for third quarter. Now, looking at this, how many times would I have to do this to get through the whole 3 years? Yeah, 12. 4 times a year for 3 years comes out to 12 times. I don't want to do this 12 times. That seems like a lot of work to me. So let's look at a shortcut. If I look at what's going on here, each quarter, what I'm multiplying by is that 0.08 times 1/4. 0.08 times 1/4 is 0.02. What this is saying is this is 2% interest each quarter. Which makes sense. If it's 8% interest for the whole year, the interest for a quarter should be 1/4 of that, or 2%. And if you look at what we were doing in one of those opening examples, take the beginning balance, we're going to add the interest, get the ending balance. For each quarter. And as we said, each of those items is described by a percent and a dollar amount. Well, the beginning balance is 100%. That's our base amount for that quarter. The interest we just said is 2%. 100 plus 2 means the ending balance is 102%. If I go back up here and look, in quarter 1, if I had just taken my beginning balance of 4,000 and multiplied by a rate of 1.02, which is 102%, I would have got 4,080. And for quarter two, if I'd have taken that 4,080 and multiplied by 1.02, again, the 102%, I would have got the 4,161. So each quarter, rather than finding the 2% and adding it on, I can just find 102%. That's my ending balance. Each quarter, I'm going to take that balance and multiply by 1.02, which means I'm going to multiply by 1.02 12 times. We said we have 12 quarters here. Well, in math, we have a method, a shortcut, if you will, for multiplying by the same number over and over again. That's an exponent. So 4,000 times 1.02 to the power of 12. That's saying we're going to take 4,000 and multiply it by 1.02 12 times. Gives us 5,072.97. Now compare that to that's the compound interest. Compare that to the simple interest balance that we had at the end of the 3 years, which was $4,960. So there's an extra $112 worth of interest here because of the compound interest. Compound interest is actually an extremely powerful tool and makes a difference over 3 years. It really makes a difference over longer periods of time. So at this point in the course, there's a couple of examples that I always feel like I have to show you just to feel like I'm doing my job. Show of hands, how many of you are under 25 years of age? Okay, so we got a little bit of an older group, not a big deal. Let's start out with age 26. Now, of course, retirement, well, this is now. According to Social Security, you guys won't be able to draw full retirement until probably 68 or 69 years of age. Actually, I should be fair. They've already said for my age group, it'll be right around 69 years of age. 67 is the full retirement age for people that are retiring this year. I think it's every month after like 1965. Or every year after 1965 that you were born, you have to delay 1 month. So for me, it'll be about 68 years of age. So for many of you, it'll be 69 or 70. But let's just go age, keep the numbers even. Let's go age 66. That's 40 years between now and retirement. Now, this is something I kind of throw out there for my students as food for thought. Right now you're in school. Typically means you're probably living a little bit cheaper. Maybe you're living back with parents. Maybe you have a roommate. Trying to figure out, maybe cutting back your hours, working part-time, whatever. Trying to figure out how to make time to go to school, and that time that's being taken away from work, how you balance your bills. So typically you're living a little bit cheaper, driving that old car, whatever. Once you're done school and you get out there and you're working, making pretty solid money, a lot of people want to move into a nicer place, want to get a new car, new truck, and because you can afford it. But what if you waited a year, kept living like you did as a student, drove the old car, kept the roommate for a year, stayed living cheaply like you are as a student? It'd be pretty easy to put some money away. Do you guys think maybe $5,000, $6,000 would be possible to put away in a year if you stayed like that? let's use $5,000 just to keep even numbers. I believe, I know a few years ago, the IRS raised it to $5,500. I think this year it goes up to $6,000 that you are allowed to put away every year in IRAs, retirement accounts that have tax advantages. But we're going to stick with $5,000. If you look at the stock market, and I'm not talking going to a bank, I'm talking about going to an investment planner and having them help you invest your money so you're not getting 0.2% interest at a bank. If you go to an investment planner, especially right now, rates have really been kind of soaring on some things. The average 40-year gain in the stock market is actually between 13 and 14% a year. So let's figure that you can actually come out 12% per year. So what that means is that $5,000 times, now 1.12, that's your 100% plus your 12%. That's 112%. Remember, your ending balance is your principal 100% plus your interest of 12%. To the power of 40, because it's going to be 40 years. This is our formula for compound interest. 5,000. Of course, this is compounded just once a year. That's why it stayed as the 12. Times 1.12 to the power of 40. Now, before I hit equals here, anybody want to guess? It's actually kind of an impressive number. We get 465,254.85. We're just going to round it to $255. $465,000 40 years from now, just by investing one $5,000 amount now. So that was at age 26. What if you decide once you get done, once you graduate and you get a better job, you decide, you know what, I worked hard to get through school. I want that new truck. And I want to live in a nicer place. And I want my boats and my four-wheelers. I want to enjoy life now. I'll worry about retirement later. Well, let's say you play with your money for a while, and at age 36 you decide, okay, now I'll start to put money away for retirement. You put away that same $5,000, and let's say you can still get 12% a year, but now it's only going to be for 30 years. You only have $149,800. You get about less than a third as much by waiting that 10 years. Now, let's say you mess up and you wait till you're about my age. I'm 47, but we're going to go age 46. And I won't say that's a screw up. It's just you've lost a lot of the advantages of investing when you're young. Now it's only in there for 20 years. Once again, you've lost. You only get less than a third, $48,231. This to me is huge. Starting young, even if you are in your 30s or whatever age you're at, now is the time. As soon as you can, start putting money away. Most of you, once you get a full-time job, after some sort of probationary period, you'll have some sort of a retirement matching, a 401k matching, tax shelter program. Take advantage of it. Even if you can only put away $50 a month, put it away young and see the difference in growth. The person that started at 26, that one payment is almost 10 times the amount that that one payment, the same $5,000 payment did for the person that was 46. In fact, since we have a minute here, Let's do the actual numbers. So let's start out at, now 21 is typically what I start out at, just to show people that power of the age. And we'll go up to 67, which is what current full retirement is. Okay, so let's do this. Anybody want to guess if you started at 21 and put away $5,000 a year, what it would be at age 67? Kind of a scary little number. Oops, what happened here? Come on now. There we go. That balance there, it'll be a little bit easier to see once we get the formatting to come up here. Or maybe formatting won't come up. There it is. Somewhere around $8 million if you invested at 12%. Now, even if you go conservative, let's say you invest it at 10% instead of 12%, because you don't want to take the risk of losing your money. Now, it's going to make a huge difference here between 10% and 12%. It drops down to only $4 million, but still, that's a significant retirement account. Now, let's play with some numbers here. Let's say you stick with a little bit more conservative 10% investment. Let's say this person here is going to play with their money. They get done with school. They say, you know what? I want to buy the new car, move to a nicer place. I'm going to play with my money for 7 years, actually 8 years. And at 29, I'll start saving. Well, 29 seems pretty young to start saving. Seems reasonable. Have fun in your 20s and then start worrying about retirement. You still get $2 million. Here's the scary part, though.
So
This person here is, what's that?
Since we're already on the subject of like 401k retirement plan stuff,
Yep.
now there's two different kinds of 401ks. There's a taxable one that is taxed when you put the money in, and then there's one that's taxed when you take it out.
Yes.
Now,
A regular 401k, you get a tax deduction when you put the money in, and then when you take it out, you pay taxes on the whole amount, which is the principal and all of the interest. Then there's a Roth 401k where you don't get the tax deduction now, but when you take it out, there is no taxes on it. To me, I would rather pay taxes on the $5,000 now than on the $100,000 that it turned into 40 years from now.
yeah. Well, the reason I ask is because I know a lot of times too, if you take out a bunch of money that's then being taxed, it counts as your income, and then you would lose any benefit you have from being retired.
Well, and if it's there's a lot of little intricacies with that I would recommend that that's something you talk to an investment planner with to get all the details. But yeah, the tax ramifications are very different. The ones that you pay the taxes on before you put it away, that doesn't count as income when you take it out. The stuff that you get the tax break on does count as income. it doesn't count against Social Security or anything like that because it's not earned income. So for a lot of those things, there's a difference between earned income and unearned income. So it shouldn't like affect your Social Security benefits or anything like that, but it will affect your taxes. It can throw you into a higher tax bracket. Okay, so this person here said, you know what? I'm young. I want to work hard. I'm going to keep living cheaper, and I'm going to put my money away. So from 21 to 28, for 8 years, they put $5,000 a year away. Then at 29, they said, I think I've done enough. I'm going to play with my money for the rest of my life. They end up with more money. This person here invested for almost 40 years, for 38 years, from 29 to 67. This person only invested for 8 years, but ended up with more in their retirement. That's because before this person started, this person already had $60,000 in there. And the interest kept building. That's the power of being young. No matter what age you are at, the next 10 years of your life is worth more than the rest of your life as far as investing for retirement. So the attitude of saying, I'm going to wait a year or 2 years, and then I'll start investing, that year that you wait actually costs you 4 years at the end of your retirement. Just because it would take that many years later in life to catch up to that year you missed. So I'm going to get off my soapbox. That's kind of my little sermon to people. Start young, do the investing now, and you'll really see it in your retirement. If it's something you're interested in, I would suggest you talk to an investment planner. There's several of them around. There's Fidelity, Edward Jones, Prudential, State Farm has an office in Rice Lake.
Well, Principal does all of the 401k stuff for Henry's.
Oh, sure. And that's another thing is 401k stuff. You have to work through the HR office where you work to see because they have to send that check out every month. You have to work with a company that they support, so that it's a place where they're sending the money to already. Out of the little book, it's units 22 and 23. Discounts and interest. Do the odds. Remember, tomorrow is our unit test. If you want to come to class, you are welcome to. I will be here. Otherwise, the test will appear on Blackboard at midnight tonight, and it'll be available on Blackboard all day tomorrow. At some point during the day tomorrow, you need to access that test, complete it, and submit it in Blackboard. Like I said, I will be in class tomorrow. If any of you get a chance to start it before class, or if you want to come in and work on it during class, I will be here to answer any questions you might have. Otherwise, I'm guessing many of you might want to take the extra little bit of time to sleep and work on it later in the day. So, that's about it for us today. So I'll see you all later. Have a great day. And if I don't see you tomorrow, we'll see you Friday morning.
See, Todd?
Yes.